My name is David Berube. I'm a professor of communication at North Carolina State University. I direct a program entitled the Public Communication of Science and Technology. We do research under an NSF grant for a nanotechnology interdisciplinary research team where we track announcements and press releases, both digital and print, as well as nano products. What you will see are two students who will present our top 10 nano products and top 10 nano developments for 2009. Thank you very much.
It was in December 1959 that Richard Feynman first delivered his speech, "There's Plenty of Room at the Bottom," a talk many associate with the birth of nanotechnology. With the end of 2009, we celebrated the 50th anniversary of this significant speech, which for some was the 50th anniversary of nanotechnology. Let us now look at the top 10 developments we witnessed this significant year. Number 1. Nanotech Bill. The House passed the nanotechnology bill that was identical to the one approved by the 110th Congress. Bart Gordon, the representative from Tennessee, sponsored this bill, which was introduced on January 15, 2009. As per the bill, the National Nanotechnology Initiative had to develop a plan for the environmental and safety research with a clear assessment of their short and long-term goals, their means to achieve it, and details about every department that will be involved. The bill also aimed to improve technology through industry tie-ups, multi-agency R&D efforts, and introduction of nanotechnology education initiatives in undergraduate levels. The bill was received and read twice in the Senate and was referred to the Committee on Commerce, Science and Transportation. Number 2. Obama and Nano. President Obama's visit to MIT in October 2009 showcased his positive views on technology by calling nanotechnology neat stuff. After touring the MIT research laboratories, the President felt that technology helped us achieve unparalleled prosperity and that each individual today is an heir to a legacy of innovation. He felt that every nation around the globe is involved in a peaceful technological competition, and the country that wins will lead the global economy. Number 3. Budget and funding. The National Nanotechnology Initiative budget was set up to be $1.5 billion for 2009. The NNI budget for research on fundamental nanoscale phenomena and processes improved from $481 million in 2007 to $551 million in 2009. The instrumentation research, metrology, and standards were designed to get $82 million. Nanomanufacturing research was assigned $62 million, and environmental health and safety R&D funding almost doubled from $35 million in 2005 to $76 million in 2009. The Japanese Ministry of Education, Culture, Sports, Science and Technology planned to allocate 35 billion yen towards nanotechnology, and the Russian government announced that it was going to spend 318 billion ruble into nanotechnology. Number 4. Centers and collaborations. There were new centers inaugurated and new collaborations established throughout 2009. The UK launched a new Centre for Nanosafety, a research centre set to analyze nanomaterials entering bodies of living species. MIT launched collaboration with the International Iberian Nanotechnology. Spain and Portugal agreed to set up a collaborative nanotechnology research center. The Supervisory Council of the Russian Corporation of Nanotechnologies approved the concept of RusNano nanotechnology centers that will provide infrastructure facilities to commercialization of nanotechnological advancements. Number 5. China controversy. The European Respiratory Journal released a study of 7 Chinese women workers who were diagnosed with severe lung damage due to nanomaterial exposure at their workplace. These exposures led to death for 2 of these women whose tissue samples and lung fluids were detected to contain 30 nanometer particles. The 2 women passed away within 2 years from the exposure, and the rest had not shown any improvement even though they were no longer handling any nanomaterials. Number 6. Nanorust in Mexico. Rice University's Center for Biological and Environmental Nanotechnology announced the release of Nanorust, the arsenic removal water purifying technology. Nanorust consists of magnetic nanoparticles of magnetite, which chemically bind with and remove arsenic from water. This is a low-cost and effective method to purify water. An additional benefit is that it removes gastrointestinal disease-causing waterborne viruses from water. Number 7. Cancer research. Research related to cancer in 2009 focused on detection and destruction of cancer cells effectively without harming adjacent healthy cells. Researchers at the University of Toronto developed a microchip of nanomaterials to make a quick analysis of the type and severity of cancer within 30 minutes. UK scientists developed tumor-busting genes that selectively destroyed cancer cells without harming the healthy ones. MIT researchers developed a device consisting of magnetic nanoparticles coated with antibodies to track or monitor the tumor growth after a biopsy or chemotherapy in a patient. Number 8. Solar energy. Cornell researchers developed a solar cell called a photodiode from a single carbon nanotube. This photodiode was nearly an ideal photovoltaic cell as electrons moving through the nanotube produced more electrons using the photon energy from light. Another study conducted by researchers at Georgia Tech and University of Wisconsin-Madison resulted in an integrated solar energy harvesting device that is a combination of nanogenerators and solar cells. The device generates 0.6 volts of solar power, 10 millivolts of piezoelectric power, and could be upgraded using multiple nanogenerators. Number 9. Protein nanoparticle interactions. A quantitative approach emerged to analyze interactions of adsorbed proteins or nanoparticles in a biological medium. Ulrich Nienhaus and colleagues examined the process and the lifetime of this interaction through fluorescence correlation spectroscopy. They used human serum albumin on polymer-coated iron platinum and cadmium selenide zinc sulfide nanoparticles. They found that a nanoparticle could only accommodate a certain amount of proteins on its surface, and that both nanoparticles and proteins need to adapt their structures to establish a stable interface. They also found the mean residence time of albumin on nanoparticle surface to be around 100 seconds, a short duration for biological processes. Number 10. Germany opposed the nano label. A single regulation was created by the EU member states that incorporated the existing 55 directives to adopt new rules on marketing and safety of cosmetic manufacturing. Germany resisted the idea of having to mention nano in brackets after every ingredient that is smaller than 100 nanometers. Germany considers that highlighting nanomaterials in products could be considered as a warning by many consumers. The German official stressed that any cosmetic product containing nanoparticles should have already passed through stringent safety tests and should not necessitate additional inquiry.